Hello everybody. I would like to talk about electric field due to an arc of charge. This is Professor Dr. Fatema Mirek. Okay everybody, I'm talking about the electric field calculation at the center of the arc. In physics, an arc is defined by an angle and radius r, angle phi and radius r. Okay, so here you see a figure of an arc which contains some charge q. Assume our charge q is uniformly distributed throughout length of the arc with the linear charge density lambda. In fact, the calculation is similar to the calculation of the ring of charge. In fact, this arc can be considered as partially of the ring. Okay, so if the length of our arc is L, we have this approximation, everybody. There is this relation between arc, length of arc, and radius and the angle. In fact, L equals r theta. This is the general equation, how you can define any arc in physics. Okay, therefore we take differential. dl means this is small element equals r radius multiply this small angle d theta. Therefore, everybody, q equals lambda l or dq equals lambda dl. Therefore, q equals integral lambda dl. Therefore, q equals lambda L itself equals r theta means your general angle. In this case, since the theta we have phi, everybody. Therefore, q equals lambda r phi. Okay, so because we want to get benefit of the symmetry, we may choose the point O is the point that we want to consider or measure the electric field. Let me assume we set up our x and y axis. X is passing through the midpoint of the arc. If we do this, we can get benefit of symmetry. So again, this one, everybody, if this one is dq, this must create a vector dE, such as here. This dE itself has two components, dEx and dEy. Again, due to the symmetry, dEy will be 0 and we have only E net along x-axis. Just x component of the electric field will be non-zero. Therefore, dE total will be dE multiply cosine theta. Okay, you have to imagine, draw it on your paper and find the angle theta, everybody. In fact, theta is a general angle from here to this point. Theta starts from half pi minus half pi to positive half pi. Theta is varying here from minus half pi to positive half pi. Half phi, sorry, half phi, not pi. So the angle is phi, minus half phi to positive half phi. Okay, therefore dE, as we know, is kq over r square. Multiply cosine theta, dq is k, dE equals k, dq. dq, everybody, itself is lambda dl. Multiply cosine theta divided by r. R is the distance from the point that you want to consider the electric field to the point of element, your small dq. From here to here means radius of the circle. It is equal r. Then you substitute r into the denominator. Once you want to integrate here, you take all the constants outside. Then we have this term. We integrate, everybody, from minus half phi to positive half phi in order to cover all the length of our arc. Okay, here again we have a typos mistake. Never mind, lambda has been written 2 times. We have to ignore this one of them. Therefore, here we continue with the integration, everybody. That's a simple integration. Finally, we get this equation. Therefore, we can summarize electric field due to any arc at the center of arc equals the net amount of the total charge divided by 2 pi epsilon 0 r square sine half phi over phi. If phi is the angle that your arc is made, we have sine half phi over there. Hello. Okay, we continue the discussion, everybody, by having some example about calculation of arc. Look at the figure, everybody. In this figure, we have our Cartesian coordinate x and y. Origin is here. We have three concentric rings, or partially 1/4 of a circle. Each one of these arcs, everybody, three different concentric rings. Each one of them acquires some charges. For example, this arc has radius r, angle, how much is the angle? Half pi. Okay, and it acquires positive q. Second one, which is concentric, all of them have the same center, has the radius 2r. It contains the total charge minus 4q. Number 3, the radius of this arc is 3r and it has total charge positive 9q. What is the question? You supposed to find the direction and the magnitude of the electric field at the origin due to all these three arcs. Okay, first of all, you have to pay attention, everybody. The angle, according to our main equation that has been described in the previous slide, the equation contains sine half phi and also sine, and in the denominator of the fraction we have phi. So phi, everybody, must be written, don't forget, must be written in terms of radian. Okay, so E1, everybody, we have the total charge here is positive Q, means E about electric field created by the first arc. Total charge is Q, R denominator, the radius is R, phi is half pi. I have to delete this phi, half pi is enough, everybody. And sine, so the angle that this arc makes is pi over 4. Sorry, half pi. Half pi, but we have in the equation, everybody, we have phi over 2. That's why here we have sine pi over 4. Into the denominator, everybody, phi itself is half pi. Okay, so then the final answer about E1 is this term. So sine pi over 4, this term, and the constants. In fact, our last answer, everybody, is represented in terms of epsilon 0, q, pi, and r. Okay, have a look the second one. Second electric field is due to the second arc. The radius is 2r, total charge is minus 4q. However, the angle of the arc is common for all these three different arcs. This is going to be the last answer. However, E3 with the radius of the arc will be 3r and 9q. Finally, we have this answer. These are the amount of electric field due to each one of them. However, in order to find E net, everybody, you have to look at the superposition. E total, since each one of the electric fields are vector, equals E1 plus E2 plus E3 in vector notation, not in a normal sum. Now, everybody, it's your job to find the direction. If this one, everybody, is the charge uniformly distributed on the length of this arc, in the previous slide, everybody, it's been proved that due to the symmetry, direction of the electric field due to any arc is passing through the midpoint of the arc. Therefore, if this angle is 90 degree, Therefore, a bisector of this 90 means 45 here, 45 there, 44 for each one of them, is the line that electric field must be passes. This one, everybody, positive here as usual. We set up a positive tiny test charge, positive, positive, repulsion. This gonna be direction of E1. Let's have a look to this one, E2, everybody, minus positive attraction. This will be direction of E2. In the same way, everybody, direction for E3 must be again repulsion, same direction as E1. I can tell you this is important, everybody. You're gonna be able to calculate E net. Then E total, everybody, will be E1 plus E2 E3 minus E2. Therefore, this will be the last answer for this example. And as you can see, the direction of the electric field, everybody, is minus 45 I. Okay, let me have a look to this example, everybody. So we have here a semicircular non-conductor rod which holds the total charge positive Q uniformly distributed around it. Calculate the net electric field at the center of the arc or circle, or at the origin. Point P is the point that we try to find the electric field. Nice and simple with the simple description. Okay, there again, everybody, we have an arc. What is the angle for this arc, everybody? As you can see, is contain a half circle. Therefore, the angle phi must be pi. However, in the numerator of the main equation about the electric field of arc, we have half pi. That means half phi. Okay, half phi means half pi for this question. Here we have pi. Nice one. Again, we got this last answer. What do you think about the direction? According to our discussion, everybody, direction of the electric field must be passing through the midpoint of the arc. Midpoint is here, this axis. If this one, we call it x, then since it is positive, so the direction of the electric field will be along positive I hat. Okay, everybody, have a look to this nice question. Here we have again two circular pads. Each one of them uh, contain a quarter of a circle. So this one from here to this point acquires positive Q. From here to this point, another one quarter, which are concentric, has acquired minus Q. Calculate the electric field at the center. Okay, again, everybody, we must have two fields. Okay, one of them, if I take a pen here and draw the vector, if I call it number 1, everybody, so the electric field due to this one, positive, positive, repulsion. This will be about the electric field passes through the first one, first arc, this one, which has the, in fact, the angle 90. Okay, this is E1. What is the angle that E1 makes with x-axis? If this one from here to here, this one is x, everybody. What is the angle? You can guess, and easily we got it before. This angle must be how much? 45, because it must be passes through the bisector. So the line passes through the midpoint. Have a look to this one, everybody. Minus positive attraction. This gonna be E2. However, E1 and E2 will be same into the magnitude. Okay, so each one of them must be obeyed by this equation. So the charge is Q, the radius is R, and the angle phi for each one of this 1/4 is half pi. Here we have sine half phi. That means pi over 4. Therefore, we get this number. This is about Q E1, E2. In fact, this value is same as E1. It is also equal to E2. Okay, what do you think about the superposition or E total, everybody? So in this figure also it's been described. So each one of these two electric fields, everybody, has two components. I wanted to draw y-axis, but a little bit, in fact here I have problem, that's not good, never mind. So E1, everybody, x component directed to the right side, E1 E2 x component is here. Since the value of each one of these two electric fields are the same, then E1x and E2x are the same. Then what happens? Due by the symmetry, this will be cancelled. In fact, E1x and E2x are the same and will cancel each other. The final E, everybody, E total will be E along J, means down here. This one is E1 Y. Here we have E2 Y. Okay, therefore E total, everybody, equals 2 multiply 2 times E1 Y. That means Y component means sine 45. That this coefficient will be appeared. Sine or cosine 45 for this case equals root 2 over 2. The coefficient 2 appears here because E total equals 2 E1y. Means 2 multiply E multiply cosine 45. Finally, we get this answer, everybody. Don't forget about the direction. Okay, so this will be the last answer to DE or E cosine theta. It will be minus J hat. Okay, the last topic of this chapter, everybody, chapter 1 of the textbook, is about motion of a charged particle. It's in an electric field. So what happens, look at the figure, everybody. What happens for an electric charge, something like Q, if it moves with the velocity v inside of the electric field? In fact, everybody, if an object has an electric charge Q at a point in a space in which there is electric field E on there, the force on the object is given by multiplication of Q multiply E. In fact, it experiences a force since it is inside of the electric field. The electrostatic force F equals EQ. So Q, everybody, is the net amount of charge. If we assume it's electron, we can, instead Q, we can substitute E. On the other hand, everybody, we have the acceleration. According to Newton's second law, F equals ma. Therefore, these two terms are the same. However, if you have a look to the kinematic, everybody, we had an equation v square plus minus v0 square equals 2 multiply acceleration multiply x, the distance that the particle is traveling. Okay, so for this case, everybody, instead A, we can substitute if we assume the electron initially
is doesn't have any speed, in fact its initial speed is 0, then finally we can have v equals this term. Thank you for your attention, everybody. Don't forget to subscribe my channel. Don't forget to like and write your comments in case you have question. Don't forget to text me. I can answer you.